Ever wondered how electricity travels hundreds of kilometers just to light up your home the moment you flip a switch? Today on Knowledge Hub, we're tracing that entire path from raw energy at the power plant all the way to the circuits inside your house. It all begins at the power plant, where different energy sources from burning fuel to rushing water to spinning wine drive huge turbines that turn motion into electricity. These turbines spin huge rotors inside generators, armed with copper coils, and through electromagnetic induction, alternating current is produced, typically at voltages far too low for long-distance travel. Sending low-voltage electricity across hundreds of kilometers would lead to enormous losses due to resistance, so immediately after generation, the power enters step-up transformers that raise the voltage to extraordinary levels such as 220,000, 275,000 or even 400,000 volts, allowing the same amount of energy to travel with dramatically lower current and far less heat loss. Only then does electricity enter the high-voltage transmission grid, a network of steel towers, ceramic insulators, and thick aluminum conductors stretching like arteries across the country. These lines constantly balance supply and demand in real time, coordinated by national grid operators who monitor frequency, usually 50 Hz, to keep the entire system synchronized. As the electricity nears towns and cities, it flows into massive substations filled with switchgear, transformers, bus bars, surge arresters, and protective relays. Substations perform the critical job of stepping the voltage down to medium levels, 33 kV or 11 kV, while also routing power through multiple feeders, isolating faults automatically, and maintaining system stability even during storms, lightning strikes, or sudden spikes in demand. From here, the power travels through regional distribution networks, using underground cables in cities and overhead lines in rural areas. As it approaches individual neighborhoods, smaller distribution transformers mounted on poles or locked inside green ground cabinets reduce the voltage once more, this time to the familiar 230 volts you use at home. The electricity then enters your property through the service drop, passes through your energy meter, and flows into the main consumer unit or breaker panel, where individual circuit breakers separate your home into safe zones, lighting circuits, plug sockets, high-load appliances, and special safety-protected circuits for areas like bathrooms. These breakers constantly monitor the flow and instantly cut off power during overloads, short circuits, or ground faults, protecting both your wiring and your devices. And all of this, the generation, the voltage stepping, the long-distance transmission, the regional distribution, and the final delivery, is happening continuously and flawlessly every second, so that when you press a switch, the lights come on without delay. This is a global network of engineering marvels, working in perfect synchronization, just to power your everyday life. If you enjoy uncovering the hidden systems that run our world, make sure you hit that subscribe button, so you never miss a new breakdown from Knowledge Hub. And as always, stay curious.